This is my new solar energy system at the moment. I've worked on it during the autumn and the winter. The two 24 volt batteries are completely dead at the moment. They were overcharged and undercharged. They had a too low voltage and broke down within 3 weeks or so. So I've made a complete new circuit here, again experimental. It consists of a Schmitt trigger that switches a car relay, and the car relay is now in the middle of the screen. This relay can handle 20 ampere, 30 ampere and is driven at 12 volts. Has a DC resistance from approximately 80 ohms or 100 ohms, and here is the unit to switch it on and off by means of the main supply. I found out that even a very small current, when it's taken constantly from such a battery, can damage the battery when the voltage gets too low. And that's why I made this circuit. I hope it's visible. I'll do my best. I cannot, I have to pan a little bit because it gets unsharp when I do this. In the middle of the screen now you see the Schmitt trigger. The first transistor is on the left side, BC507B, and there's a whole bunch of 10 ohms resistors here. They go up and to the 24 volt battery, and in the middle of that bunch there is a lead to the first transistor, the BC507B, and here is the Schmitt trigger. It's a well-known circuit. I have already published it on YouTube, and I have to say that this whole bunch of transistors are quite precise. You have to find out it very precisely, experimentally, and take the voltage divider, make the voltage divider in such a way that it switches off the battery at the right voltage. And that's not 21 volts or so, it's approximately 23.5 volts. Here you see how the Schmitt trigger drives another unit, and that's the unit with which we drive the car relay. That's now on the right side, under, so this is the car relay. And this car relay makes the batteries, the 24 volt 80 ampere hour battery, available for lighting in the room. So when there's enough light and when the batteries are well charged, the Schmitt trigger switches this car relay to another position. And when the battery is too low, the car relay switches back and sets the power transformer that's inside here available. I have to test it. I have only tested it in my my attic lab, my lab where I make so many videos, and I found that it switches quite precise, and I hope that it will work, but I have to buy new batteries. I'm gonna do that in February, and then I can test whether this circuit works properly. It switches properly in the laboratory situation, and again, when you want to use this circuit for another application, you have to find out here this voltage divider, so where to connect the this lead to the first transistor to make it work properly. Switch it on the voltage that you want. And as you can see, I've mounted it all on varnished wood with brass nails. I've used ceramic coupling units now in the middle of the screen, not so very well visible, because the thick wiring from the battery can get warm. So use good materials and good wiring for such a circuit. It's very sloppy, but it's in an experimental phase.